Okay, let's get started. So does anyone have any questions? Yeah.
What does it mean to initialize a variable?
In what context?
In the context of what you talked about.
Okay, so in terms of initializing a variable, like here, I'm not initializing the variable size to a particular value necessarily, but here I am initializing it to a value using the assignment operator. So when I initialize it, I put some value, either another variable or a literal, as we'll see today, and then the thing on the left, the variable will now be initialized to that particular value, whatever was on the right side. Other questions? So is this second statement right here, is that initialization? No, what is it? It is an assignment. So the initialization happens right when you first declare the variable, but in any other context where you just have the variable, no int or whatever next to it, that is an assignment. So initialization is when you first make the thing, and assignment is any other time. Other questions? Yeah.
So when it says int size, that means you're energizing the size?
No, I'm not I'm creating the variable, but I'm not initializing it to a value. I'm not giving it a value to be initialized with. Whereas the second one, yes, I am. So what starts today? Labs. So should you go to your lab section? Yes, good. Other questions? Yeah, way in the back.
So, I have two questions. We can miss one lab.
So some instructors get really micromanaging and say, if you miss this number of labs, then they technically could give you whatever grade, failure or whatever. So I don't take that into consideration. Yeah, it's just too much work on our part.
How do we know which data corresponds in our lab?
It's on the course page. Yeah, so right where it says the links for all the labs are at the very bottom, I have each of the 3 TAs is assigned to these 3 labs. Other questions? Okay, so stop me at around 9 o'clock if I go over. All right, so last time we were talking about these variable things, right? So we just talked right now about initialization versus assignment. And here it just says you can have, if you want to initialize, if you want to create multiple variables of the same type, in this case, whatever this int thing is, then you can put a comma in between on the same statement, like in the second line right here, where it says int length, comma width, and now I have 2 variables, both of type int, whatever that means. So just one more thing before we get into more juicy things. So what a literal is, you may wonder, well, we have these variable things, but we have this 12 or 5, right? We have these things written to the program, but we can't assign to them, and we can't change their value. So I can't, even if I wanted to, change the value of 12 to value 13. So here, that's what's called a literal. So a literal is, so this sentence right here is a piece of data, that sentence. That comes from the publisher, and I think it's a little misleading. So it says that it's written directly in the source code of the program. But isn't everything written into the source code of the program, even variables? So what I think they mean here is something that's written that does not change a value, and it's not a variable, and it's not given a particular name. So it's a piece of data written into the program. It's another way to think about it. So here, the value 12, that's a piece of data that's written into the program. It can't change value. You can't assign to it. You can't do anything with it other than stick this value here. So if I put it on the right-hand side of an assignment operation, then I can use a literal there. I can use a variable there. But in the previous example, we had a literal, the value 12 there. But of course, we can have other types of literals. So this is not an exhaustive list, but these are pretty much all the ones we'll deal with. So a character literal, whatever a character means, we already dealt with these things called strings between double quotes. In your assignment, you're going to be dealing with these things called floating points. So with different types of literals. So it's just, it's not really that important. It's just to be able to distinguish what is a literal, what's a variable. That's the only thing there. But the juicier thing here is when we want to make the variable or identifier, same thing, what can we actually name them? So I said before that I can name this anything I want pretty much. So I'm going to address what the pretty much actually means here. So just to recap, it's the name of a piece of data. So when we declared before, a few slides ago, so let's see. Yeah, so if I wanted to, yeah, so this identifier or variable is called item, but you may think, well, does it have to be called item, or can I have it be named something else? And it's quite conceivable to think, yeah, you can name it pretty much anything you want. But it wouldn't make a whole lot of sense for us to be allowed to do whatever we want, right? So if I wanted to call this identifier int, do you think they should allow me to do that? No, because then it'd be using a keyword of C++ in a different meaning than what C++ defined it to be. So, so there are some rules about what you can have. But in general, you can pretty much have any name you want that makes sense. But you want to have it in such a way that you can read it and understand what this variable or identifier is supposed to do. So if I wanted to call something x, would that be a useful name for an identifier? If I said like int x equals 12 or something, would that be useful? So, actually, in some cases it is, in some cases it isn't. So if you're dealing with something like a polynomial equation, then it might make sense to declare something to be x, because most people in that area use x as the terminology for the variable in that sense. But in other contexts, if you're building like a software application or something else, then you may want to think, is x a good variable name? And in most cases, it isn't a good variable name, but sometimes it is. So you have to be cautious and try to stick with how people use identifiers in C++. So you can't use C++ keywords. So the main rule here is that you have to start with an alphabetic character, so A through Z, or the underscore character. And then after that first character, it can be anything. So by anything, I mean alphabetic characters or numbers if you like, or more underscore characters if you like. So you can't have anything like pound sign or dollar sign or percent symbol, because those have a specific meaning in C++. Upper or lowercase, but the main convention in C++ is to have everything lowercase. In other languages, you have either complete capitals, or in camel case, or so there are other rules for different languages. In C++, you can have whatever you want, but the convention is always all lowercase. So, of course, it should reflect what it's supposed to do. You can have multiple words here. By words, I mean this. So, you can have something like this, where you just, the terminology here is concatenate all of the words together. So if I wanted quantity on order, I can't have quantity space on space order. I have to put them all together, because I'm not allowed to have spaces in between in the identifier name. But the other way that you can do it which I think is more readable in C++, is to put an underscore character in between. So it serves like a space character, but it's just the name of the thing. I can call this whatever I want, but just try to make it so that it's easier to read. Okay, and then try to be consistent. Yeah, so look at these identifiers, these 5 identifiers. So which ones are valid identifiers that C++ says, yep, that's okay, and which ones are not valid? So is the first one valid? Yeah, because it's just all letters. What about the second one? Yep, that's valid. What about the third one? No, and what's the reason? Because there's a period in there. What about the fourth one? No, why not? It starts with a number, yeah. And the fifth one? No, for what reason? Starts with a $sign. You guys are alert. That's awesome. Any questions on identifiers? Okay. Yeah, you got a question?
Yeah, so like, I'm not really catching this. So like, there's no identifier or something that's like a dot, underscore, or nothing, right?
So I'm just saying, like, what are you allowed to use? So remember back at these examples right here, So it's what can I call that? So I called it length in this case, but I'm just asking, what are you allowed to put there? Can you put something else? Because could I conceivably put X, Y, Z there? Yeah, so I'm just asking, what can you use there? Yeah, so it's the names of the variables or identifiers, same terminology. It's just what can you put there? So remember, you have to start with an alphabetic character or underscore, and then after that, you can have alphabet or underscore or a number, and as many as you like. But of course, if you have a really long variable name, that could be quite difficult to actually read. So there's nothing wrong in C++ about that, but it's just harder for a person to read and understand. Okay. Any other questions about identifiers? Okay. So let's talk about cin. So we kind of talked about this before. So cout was the way that we outputted stuff. Cin, as you might expect, is the default way that you could input stuff from the keyboard. So it requires IOStream, as you might expect, read input. So the way that you're doing it on your first assignment is you're going to cout a prompt. So you'll print a prompt to the user to input something, and then you'll use cin to input something from the user. So we went over an example of that last time where we tried to square a number, I believe was the program. So we printed something that says enter a number, and then we cinned a number, that we did a calculation, and then we printed out the result. So the first assignment will be very similar to that. You print out a prompt, well, 3 in this case, then you cin 3 times, and then you do the calculations that are necessary, then you print the 3 results. And that's all you need to do. So the cin, you retrieve the data with this operator, which is so it's backwards of the cout one, where you have 2 greater than symbols. Here we have 2 less than symbols, which we haven't really gotten to all the operators yet, but it's called the stream extraction operator. But you don't need to know that yet. So remember, we could cin multiple times or cout multiple times just by repeating the particular operator multiple times. And then, so you don't really need to know this, but the way that cin works is it goes into what is called a buffer, in this case an input buffer, and then it's stored as characters, and then at some point, you don't know when necessarily, then it'll be converted to the right type for the variable that you're going for. So remember, for the program that we cin that number where we had to do the square, it's inputted as characters, but it's not a number yet. So the cin object, whatever it does some kind of conversion between these characters. It's not a number. Then it converts it to a number and then does an assignment to that variable that we're cin into. Yeah, so it converts the data to the type that matches it. So here is another example. So we declare a variable here, we print a prompt, and then cin does all the work for us. It waits for the user to enter something, then press enter. Then once the user presses enter, the input is currently just a bunch of characters, a string if you like. And then what happens is cin converts that to an integer. In this case, because height is an integer. If it was some other type, it would have to do some other conversion if necessary. So it does a conversion and then assigns whatever value was entered into that variable height. And so then right after this, then we can use the inputted value height to do some other work. Okay, so then of course, as I said, you can do it multiple times just by repeating the operator. Multiple values must be separated by spaces or the enter. So yeah, so that's what's called tokenization, but you don't need to know that. So if you enter some text and then space, text, then what will happen is cin will work until the first space. So it will not include the space, but it's just the first bit of text. If you want the entire line, then there's another way you can do that. But you must push enter after the last value. So if you do have multiple things separated by spaces, if you're cinning multiple things, then each of those chunks of text are going to go to each of the variables. And of course, the values that you're entering don't need to be all the same type. They don't have to be all integers or whatever. But the order here is important. So if I'm doing this statement right here, then the user better enter the height first and then the width. It can't go the other way. So you can think of like the operator here as the order that's going to happen. I start with cin, and then the first thing that it's going to see is height, and then the next thing it's going to see is width. Yeah. What without any? Oh, good question. So, right, so if I have some input and there's no space and I just push enter, then what would happen is that will all go to height, but then it's now going to wait again for width. So if I just enter some text without a space, it'll convert that as it needs to and put it into height, and then it'll wait again for me to put in anything for width. If I did something, I put in some text, space, some text, and then I did enter, it'll do both of them. So yeah, because it's seeing that space and thinking, oh yeah, that's the next thing that needs to be entered. And then I think we did an example similar to this, where we had to enter some text, push enter, and then put in some other text because it's waiting again. Then we just push enter. Any questions about that? Okay, so let's get on to more technical types of things. So integers. So we had this int thing, which stands for integers, I kind of indicated last time. So it's just whole numbers. But one of the interesting things about C++ is that the integers themselves can be what are called signed and unsigned. So what do you think signed means? Yeah. Right, it could be positive or negative. What do you think unsigned means? Not signed. But like in English, what does that mean? Yeah. It's only positive, but it can also be 0 too, because it's not negative. So, so in this case, 12 it could be signed or unsigned. -6 is definitely signed. But since I didn't have the plus here, I would say that that is unsigned. And then I would say +3 here is signed because it has the plus there. But you're not going to be writing like plus when the integer is positive or 0. But if it's negative, you will put the negative sign there. But so based on that, if you have a program where you need an integer, but you only need either 0 or positive integers, should you ever use a signed integer? No, because you're never going to need the negative values. But if you do need the negative values, then I would suggest you use signed. But there's a whole bit of quirkiness about how signed and unsigned values work. And that's kind of indicated by this. So remember what a byte is 8 of those bit things. So depending on how much data you actually need, how large the integer needs to be, you'll need to specify, well, how many bytes do I actually need? So there are basically 4 types of integers that you can have. Something called a short, an integer, so int, just normal int, a long int, and a long int. So I would say how many bytes each of these has, but I can't because it depends on the computer that you use. In pretty much any computer, in the int right here, that represents either 4 or 8 bytes. So it depends on the computer. Either you're running 32-bit or 64-bit. The vast majority of the time is either 4 or 8 bytes. So short int is half of that, so either 2 or 4 bytes. Long int is twice what int was, and long int is twice what long int was. Okay? So, and long int was actually pretty recently introduced because some people really do need that much storage. So for int, that, let's see. So let's say that has 4 bytes. So how many bits does it have if it has 4 bytes? 32. So if you look at this, do you think it's signed or unsigned by default? It's actually signed by default. So, so if it's signed, then the way that int works is, well, what is the maximum possible number of things that int could represent? Well, I have 32 bits to work with. Then it seems conceivable that, well, if I have 2 possibilities for every single one of those bits, those 32 bits, how many numbers can I represent? Well, I have 2 choices for the first bit, 2 choices for the second bit, 2 choices for the third bit. How many bits do I have? 32. So how many choices do I have in total? 2 to the 32. But because it's signed, what happens here is, how do you actually represent the negative values? What happens here is that one of those 32 bits is what's called a sign bit. And I think I have a slide about this too. So one of those bits is a signed bit, and then the other 31 bits are going to say, how large is this value and how negative is this value, depending on what the signed bit actually is. So if it's 0, then the number is, the 31 bits are positive, and if it's 1, the 31 bits are negative. So yeah, it allocates 1 bit for the sign of the number by default. Unless I say unsigned for the integer, then that extra bit is going to allow us to use all 32 bits to represent the number if we need to. You can declare variables to be unsigned. So if you wanted an unsigned int, you would just say unsigned int, then the name, instead of just int the name. Okay? Let's see. So remember we had short int and long int. You don't, in those cases, have to put the word int, so because it's implied that it's an integer anyway. So if you wanted a short int, then you can just say short. So before we stop for now, why would I ever want a short versus a normal integer? Because the normal integer can represent more than the short can. It takes less memory. And what you can figure out from there is it actually runs much faster. The computer runs faster if you have less data to work with. Any questions about that? Yeah.
Why do you exactly use the shrunk? It takes less memory.
Yeah, it takes less memory.
Reduces functionality.
It reduces the amount of numbers that number could represent, that variable could take hold. If you know that in advance, then you could use a short. But if you don't, then I would say int is okay. Yeah. It's just twice as much. So if you really need that much data, then I would just use those. Other questions? All right, let's have a quiz.